Okay, so in this video I'm going to have a look at the Leaving Certificate Higher Level Paper 2 for 2015, and I'm going to have a look at question 5. So part A just asks us to prove that the tan of A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So okay, let's start. Now we're just going to start by writing down the tan of A plus B is equal to the sine of A plus B over the cos of A plus B. So you'll see that from your tables that tan of theta is equal to sine over cos, sine theta over cos theta. So let's just expand these out. So you'll see from your tables that sine of A plus B is equal to sine A cos B plus cos A sine B, and you'll also see from your tables that cos of A plus B is equal to cos A cos B minus sine A sine B. Okay, so what we can do now is just divide the top and the bottom by cos A cos B, because remember sine over cos will give us tan. We have no tans here at the moment, and if you look at what we're looking for here on the right hand side is tan. We've got 4 tans here, we've got no sines or coses, so we've got to change all these to tans. So if we divide a sine by a cos, we'll get a tan. So I'm going to divide above and below by cos A cos B. So what we end up with is sine A cos B over cos A cos B plus cos A sine B over cos A cos B. That's the top line. Remember, we must divide each of these terms by cos A cos B. So this one here is cos A cos B divided by cos A cos B, and then here we have sine A sine B over cos A cos B. Okay, so now if we look at what we've ended up with here, let's do each one individually. Here we have, just looking up here, we have sine A over cos A. Well, that's tan A. We have cos B divided by cos B. That'll just give us 1. So that'll disappear if you like. We've got plus cos A over cos A will disappear as well. That'll give us 1. And we've got sine B over cos B, which is tan B. On the bottom now we have cos A cos, this should be cos B here, divided by cos A cos B. Again, that'll just give us 1. We have a minus here. We've sine A over cos A, which is tan A. We've got sine B over cos B, which is tan B. And that's it. That's it, finished. Okay, so let's move on then to the next one. That's down here somewhere. Okay, so we got to solve this. We got to find all the values of x for which sine 3x is equal to root 3 over 2, and we're looking for x's between 0 and 360, and we want them in degrees as well rather than radians. So you should recognize this root 3 over 2 is one of your sine, cos or tans of one of your kind of special angles. 30 degrees, 60 degrees, the other ones are 45 degrees, 90 degrees, 180 and so on. But if you look up your tables anyway, you'll see that the sine of theta is equal to root 3 over 2. If you look that up, you'll find that theta will actually be 60 degrees. So the sine of 60 degrees is actually root 3 over 2. So let's just write it down. We have sine 3x is equal to root 3 over 2. In other words, our 3x here is equal to the sine inverse of 3 over 2, root 3 over 2, and it's actually going to be 60 degrees. However, there are always going to be two angles that we're going to be talking about here. If you think about it, if we take our 60 degrees here, this is our 60 degrees here. But you'll also notice that sine is also positive in the second quadrant. So there is another angle here with a reference angle of 60 degrees. So in other words, this angle here also has a sine that is plus root 3 over 2, because sine is positive in the second quadrant. So what angle is this? Well, it's 180 degrees minus 60 degrees, so it's actually 120 degrees. So you'll find that the sine of 60 degrees will give us plus root 3 over 2, and also the sine of 120 degrees is also plus root 3 over 2. If we go down into the third and fourth quadrants, we will also get root 3 over 2, but it'll be minus root 3 over 2 if we stick to the reference angle of 60 degrees. Okay, so we're looking at 60 degrees. We're also looking at 120 degrees. So there are two angles that will give us a sine of root 3 over 2. Now, we've got to keep going here, because if we take this 60 degrees here and we add 360 degrees, we come all the way back around here, we'll also end up with 360 plus this 60 degrees here. We'll end up with this angle here still. So the sine of that angle will also be root 3 over 2. So we need to add 360 degrees to 60, and that will give me 420 degrees. We need to add 360 degrees to 120, because we take this angle here, add 360 degrees to it, we end up back here again. So that will be 480 degrees. We just keep adding 360, so add 360 to 420, that'll give me 780. Add 360 to 480, that'll give me 840 degrees, and we can stop there. Now you can keep doing that, you can do one or two more if you like, but you've got to remember that our x has to be between 0 and 360. These are all 3x's, so we've got to divide all of these by 3. So if we divide these by 3, we get 20 degrees, we get 40 degrees. We divide this by 3, we get 140 degrees. Divide this one by 3, we get 160 degrees. Divide this by 3, we get 260 degrees. Divide this by 3, we get 280 degrees. Now, if we'd have gone on further here and said 780 plus 360, we'd have gotten 1140 here. 1140 here. Say 1140 if we had continued on. If you divide that by 3, you get 380 degrees. Now 380 degrees is outside, remember we're solving for x here. 380 degrees is outside our limit here. We were only required to write down x between 0 and 360. So we didn't need this one here, so we get rid of this here, and we can get rid of this one here as well. This is our solution here. As far as here, these are our x's, and that's it. You can see actually that you're adding 360 each time here. If you divide 360 by 120, what we're doing here is we're adding 120 each time. Add 120 to 20, you get 140. Add 120 to 40, you get 160, and so on. Okay, so that's it for this particular question.